Hello everyone, welcome back. So in this video we are going to understand the Leetcode problem number 1878. Get biggest three rhombus sum in a grid. So the question is saying that you are given a m cross n matrix and a rhombus sum is the sum of elements that form the border of a regular rhombus shape in the grid. So the rhombus must have the shape of square rotated 45 degree and each corner centered in a grid cell. Below is an image of four valid rhombus shapes with the corresponding color cell that should be included in the rhombus sum. And if you see it is saying the rhombus can have an area of 0, which is depicted by the purple rhombus in the border corner, and return the biggest three distinct rhombus sum in the grid in the descending order. If there are less than 3 distinct value, return all of them. Okay, so very first you think about what is a rhombus here. Okay, so rhombus is a four-side quadrilateral flat shape, where if you see here, right, the green one, either the purple one or the red one, right, so these having four-sided shapes where all four sides are equal in length and opposite sides are parallel. So if you see the green one, these are parallel. For this one, these are parallel. For this purple one, these are parallel, right? Like that, if you can see that. So this little tilde square we can say, or diamond shape we can say. So this is called rhombus. Okay, further let's understand. So today we are solving this very interesting grid problem because this problem is very interesting. So if anyone is seeing this question first time, right, so it looks very complicated, but once you understand how this rhombus traversal will work, right, the solution becomes very easy. So in this video we'll try to cover everything about understanding the problem and how the rhombus traversal is working and the intuition behind the problem, and we will understand the Java code also. So keep watching and try to understand how the trick will work using the diagonal prefix sum and how we are going to solve this. So let's jump in here directly. So very first, if you see here what we have given, this is nothing but the 2D grid of numbers we have given. Okay, let me show you here. So this is nothing but the 2D grid of numbers, and our task is to what? Our task is to find the rhombus shapes inside the grid, right? Very first, what we need to do, we have to find the rhombus shapes inside the grid, right? What are the rhombus we have, how many rhombus we have, that we have to find the rhombus inside the grid. Then we'll calculate the sum of the rhombus border, right? As you can see here, like this we can do the sum. Okay, then we have to return the largest three distinct sum we have to return. Okay, as you can see here, we have given these grids we have given. So this is the three largest distinct sums. So if you see, the blue sum is this, red sum is this, and the green sum is this. We all put together and we will return. Okay, there is only one important rule is we have to understand about the rule is only the border of the rhombus counts. Let's suppose 23, 205, right? So you see 23, 200 and this 5 gives you 28. I'm talking about the purple one, right? So there is only one rule, you cannot include 30 here. Okay, the only one rule is here, we have to count the border of the rhombus count, not inside that one. Okay, so what is rhombus? Rhombus, think of rhombus as a diamond shape, right, in the grid. Okay, and inside a grid it may look like this. Okay, like we have purple one, we have green one, like that we can say that. Let's understand one thing, that the rhombus, right, let's call like this. Okay, this shape is called rhombus. Basically this is nothing but the square, right? So all these sides are equal. Okay, so this is little tilde shape of square, right? Now what will the smallest rhombus? So rhombus of size 0 will be the smallest, right? A simple single cell we can say, right? Either you can say the single cell is also called, let's suppose any of these, let's suppose we'll choose the 5 one, right? So only if we'll take the 5 value here, so this is the smallest cell, right? Single cell, and this is also called the smallest rhombus, right? So we can say this is nothing but our smallest rhombus, right? Like this. Okay, now so here every cell in the grid is technically a rhombus. Okay, let's suppose that we have given this grid. Okay, so in this grid, if we'll talk about, let's call that we have centered around some value. Okay, so what we have given, 3 4 5 1 3. Okay, then 3 3 4 2 3, then we can take 20 30 this and this like that, or we can let's take a simple one. Okay, so let's think that we have a grid 3 4 5 1 3 3 4 2, then we'll take 20 30 200 40 1 5 5 4. Let's suppose if we will take this as a grid. Okay, if this is a grid, suppose the center is, if we'll take these right, and these 4 like this, then it will come to 30 like this, correct? What is the center is here, right? We can say, suppose the center is here, that we have 4 3 4 and 30. Okay, it means what? If we choose the coordinate visited, right? If we choose the coordinate, what I'm trying to say, what is the coordinate visited? What is the visited coordinate? Okay, so what we'll say, okay, start with the top. So this top is at where? This top is at where? This top, the 4 1 is where is it is? So very first it is 0 1. This is 0 0. This is 0 1. So we'll say 0 1. Then what? This is right? 4. 4 is at where? 1 2. So the right is at 1 2. Then 3, right? Or you can say 30. Last one, the 30 is the bottom, right? So we'll say bottom is at where? So we'll say it is this is 2, right? So 2 1, this will go to the 2 1, and the last is left. So last coordinate is 3. So where it is the left one, and this left one is 1 0, right? Now let's do the sum. So if you do the rhombus sum, right, what you will come? We'll say 4 4 30 3. So 4 4 8 30 38 and 3 41. Total 41 it will come. Okay, so this is the way, if we'll understand the coordinates, right, we can find it, and we know that the each cell, where is each cell having. So very first you need to find the coordinates, where is the top is there, where is the right is there, where is the bottom is there, right? And then you will find it. So if any parameter matching, you have to find it where it is going, right? Like this, you have to count this one, this one, this one, and this one, and you got this 228. Similarly, we have 2, we have 10, we have 4, we have, and 200 we have. All you have added, you get 216. Then you will 200, and only you will add 205 4 and 3, you will get 220, like that, right? Means you have to find its cells, you know the what is the coordinates we have visited, right? the coordinates visited, and then we'll calculate all the sum here. This is the rhombus sum, and the rhombus sum become is 41, right? Let's understand how do we traverse a rhombus. Okay, let me clean it. So one thing you understood, that each rhombus has 4 edges, right? Let's suppose for this case, edge 1, edge 2, edge 3, edge 4, right? We can say. So each having 4 edges. So we traverse them one by one. So let's say you will say, okay, edge 1. Edge 1, when top right is there, right? So we will say, okay, let's do the movement. How will you do the movement? Means how will you do the movement? You will say movement should be like the row plus plus and the column plus plus, like that, right? Means you will keep increasing the row side, right? Because top right, if this is top and if this is right, so you will go with this one very first. Means our movement will work like this. These are the cells, okay? So it will keep, so row is increasing, column is increasing. So our diagram for the top right, it will move like this, correct? Similarly, if we have edge 2, so let's suppose edge 2 is right bottom. So if suppose that if right bottom will happen, means what is the movement will be there? Moment, right? Let's suppose in the grid, we have already seen that the grid will work, right? Means you know that the top right we have came. So let's suppose already we have visited these 3. Once you come to the right, you have to go to the bottom, right? Like this you will go. Okay, so this part I'm talking about. Okay, means in this case what you need to do, you will say row plus plus, but column should be minus minus, correct? Similarly, if we have the can I clean it? Let me clean it. Similarly, the edge 3 we are talking about, when we'll do the bottom left, what we will do, we'll do the movement, right? So movement will work like this. How? Bottom left. So from the bottom we have to go like this, right? This diagram I'm talking about. So we have already covered this part and this part, right? We have already covered. So how will you do that? So we'll say, okay, this time we'll say row should be minus minus and the column should be also minus minus. This case, when the bottom to left will go, both should be minus minus. Okay, when we talk about the edge 4, means the left to the top. Okay, how will it work? The moment we say row minus minus, but column will be plus plus. Why? Because from the left here, right, will go to the top. It means column is increasing but the row is decreasing, right? So these together, these edges creates the rhombus border. So we have to follow all these edges calculations. Basically what we want for the solution, like what the intuition we want for the solution is, the very simple idea is for every cells, right, for every cell in the grid, treat it as a top of a rhombus. Okay, so when you, this is your top of the rhombus, you know, we expand the rhombus downward, right, and we'll compute the border sum first, that we know how to do that, right? Then we will store the top 3 sum in the in somewhere, right, in the grid or somewhere, right? Let's suppose you will store any 3 values, let's suppose unique sums, but we have to compute each edge directly. That would be slow, so we'll use powerful trick. So what is the powerful trick? Let me show you. So basically we will use diagonal prefix. Okay, so diagonal prefix we will use. So 2 prefix array we need, prefix arrays we will need. Let's call someone will get from where? Diagonal, which is coming from top to this, and sum 2 we will take when the diagonal, this is diagonal 1 and this is diagonal 2, when diagonal come from top to down, like this, right? So the direction this and this, let's suppose when we are talking about the direction this one, it means what? Let's suppose 1 2 3 4, this is happening when we are talking about this one, right? So what will happen here? 1 2 3 4, like this diagonal will go, right? So with this prefix, right, with this prefix sum, we can compute each rhombus is in O of 1 time. Okay, so this technique will speed up our programming and help in getting the better time and space complexity. Let's say that you have m as a rows and n is a column. Okay, so we will check m cross n as a centers, right, and multiple rhombus sizes, correct? So the overall complexity will come how m cross n into mean of what? M comma n. What is the minimum, right? So this will become our time complexity. Just take O of time complexity. This is the time complexity. For the space complexity, it will take all the combination m cross n. So we'll take O of m cross n. It will be very simple. Let's go to the code. We will understand here how we have implemented. Okay, so as you can see, we have took two things. We know that grid we have, so m and n we will find, then to sum we will find sum 1 sum 2, and we'll calculate the sum 1 sum 2 here. Okay, then we have our answer, right? So we will keep storing the answer, right? When we will find answer dot put, we will do, and we'll keep adding I and j like that, and we'll create a k from I plus 2 to k, this one, right? So basically we want to find all the possibilities, right, of the ux, ui, dx, dy, lx, ly, ry, means all those directions, and we'll keep checking. Then we'll do the sum, right? Once the sum calculated, we'll put into the answer, and once this is done, we will get the list of answer dot get, and we'll get the list, right? Over this we'll check the result, right? And in the list dot size, what we need to do, we'll keep adding on the result at I. Okay, so from the list you will get adding on the result I, because we have to return the result. Okay, then when we come here, I'll show you. So this is our list of answer, right, where you will add the mean value, and mean value, right? 3 mean value will added on this answer. Then this is the method we have, put method, where you will check all these values, right? If x is greater than answer, what you need to do? If x is greater than answer 1, then what we need to do? When x is greater than answer 2, what you need to do? So all these three things you will add to store the answer. Okay, then there will be a get method, from where you will keep checking on the retrieval, right? You will keep checking all the answer. It should not be the infinity minus infinity value. If it is not, we'll keep adding onto the this result, and you will return whenever the get method will get called, right? That is why if you have seen here, you have created the answer, right, and you are putting all those answer here. Once you have added, keep adding all the answers, right, as the sum, right, all the sum, what you need to do, you are returning get answer dot get, right, from where you will get the all the list, right? But the same number of answer we have to add on the answer also, right, result. So you define the size, and you are keep adding all those values from the answer to the list, our result finally returning. The same thing we are doing, that we were talking there, right? So basically, if we want to break this logical code into some parts. So total 5 parts will happen, where very first top 3 result we are storing, right? And then the diagonal prefix sum we are calculating, right? After that we are iterating the possible rhombus tops, right? So we'll keep iterating over that, and we'll find the what you call the possible rhombus tops, right? And then we are computing the corners. Once you computing all the corners, right, we need to calculate the rhombus border in O of 1 time. So that we are also doing, right? So very first what this answer will do is this is the answer we have created. Go a little up. Yeah, so this is answer class. Answer class contains answer array, right? And we are keep adding all those answer, means answer size is 3. We can say that we will keep answer size is 3. So this class keeps the largest 3 distinct rhombus sums, right? Let's say that we have seen 3 answer, right? Any of these 3 answer will store, like this answer we will store. Okay, then what we have, we need to add a put method. So this put method will check if the x is greater than the answer 0, right? Will what we will do, we will store answer at 2 is 1, 1 is 0, and the next value will come is x, right? Means we will reset 0, 1 and 2 of the answer. If x is the largest value seen so far, so shift the value right. Before, let's suppose it was we'll take the answer will contain like 8 10 8 7, okay, and we'll insert 12. So now it will happen what, 12 10 8, 7 will remove. Okay, like that we have to keep doing that. Similarly, we have get method. Basically this get method will do what is to convert the stored value into the list, and then we are skipping some empty values, right, empty entries, and we'll return the answer. Okay, then if you'll come here, what we are doing here, we are creating two in the diagonal, right, class. In diagonal class we are creating two prefix arrays, sum1 sum2 for the diagonal 1 diagonal 2, and we will maintain the grid, right? Means we will maintain from the grid we will get the values, and we will maintain the prefix sum. Then we will build the sum1 sum2 like this we have built, right? These are the diagonal value we have building, right? So purpose to build this grid 1 grid 2 diagonal is basically, if this value already calculated, so this prefix sum allow a quick diagonal sum, right? And so we'll keep going further, right, and we'll iterate over all the grid cells, right? So we will iterate over the grid, and then we'll add the single cell rhombus first. Okay, let's call the very first value is 5 that we have talked about, right? And then we are building that. So every cell count as a rhombus. We'll keep adding here. Then we are expanding the rhombus here, right? So the very first cell we will add, then we will expand the rhombus, and we'll keep moving ahead. Means k here represents the bottom row of the rhombus, and till that we'll keep going and we'll get the value. And we already know that we have already calculated that value, so we'll get the sum, and we'll expand the rhombus. So let's suppose that very first that we have added one cell, right? Then we have expanded. So in this case, let's suppose we have some element, right? So top element is I and k is at k, right? The top is I and k is bottom, right? So what will happen? The rhombus height become k minus I, right? So we will increment by 2, will maintain the symmetry, and we'll keep going ahead, right? Then we'll calculate the rhombus corners. Let's suppose we'll calculate this ux and uy. So I and z we will get, then we'll find the top vertex, right? Like that we'll create, like we have what do you call, the lx and ly, the left corner and the right corner, right? So So this is your top vertex and bottom vertex. We can say that similarly we have left and right. We can say that like we will keep finding those values, and then so you will find all those corners, right? And we'll say okay, the top, bottom, left and right corner, all you will find, and then you will check the boundary conditions. If you will only stop if the rhombus goes outside the grid, right? Otherwise you will keep calculating the rhombus border sum. So now comes the clear part where each rhombus has 4 edges. Instead of walking each edge, we will use the prefix sum, right? So what we will do, we will say okay, we have the prefix sum already, so we'll calculate all this part, right? You need the sum lx plus 1, ly plus 1, right? Like that you will keep finding all those values. So you know that this part is nothing but our edge 1, where we have the top left edge, we can say. Then we have edge 2, where we talked about the right edge. Then we talk about the edge 3, then edge 4, similarly that we have talked about, right? And these are the grid values. We know that at each grid value means top left, right left, like that we have calculated all those rhombus, right? Then we will have the each grid's value we have, means basically why we subtract the corner. We want to subtract the corner because corner get counted twice, so we will subtract it, okay? And then we'll add the sum, and further you know what we need to do. It's very easy to understand because you already stored on the answer. You will get it and you will store back to the result. So our return type is integer, so we will get easily, okay? In case you have any doubt, guys, please ping me in the comment box. I'll put the code there, and that's all in this video. Thank you so much for watching, and please like ExpertFunda and share with your friends if they're preparing. In case you are struggling with the DSA preparation, you can join my online classes. So please hit subscribe this channel and do WhatsApp to connect with me. Thank you so much. Bye bye.